Is this it? Yeah. All right, let's see with the first 8. Okay, so this is question 8b from the homework. First one, we have cosine 2x is equal to 1/2, and I need to think about what the domain is, and that's between 0 and 3. Is this you, right? What was the first step here, maybe? Okay, so that was the question. This is the answer. So a change in the domain is 2x now we're dealing with, so that needs to be doubled. So 0, this needs to be doubled. 6 pi, very good. And then in general, cosine theta is 1/2, but we know what, in general what our reference angle would be, don't we? Really well, don't we? Cosine what is 1/2? Not going to ask 2 people. I'm going to ask one of the other people. Riley, what's cosine 1/2? Pi over 3. Sure. Anyone want to disagree with that? Nope. Okay, so that's good. Pi over 3, sweet. All right. Well, we need to think about where that is, and then we need to think about how many times we need to go around the circle. And all our answers when we go around the circle are the answers for 2x, aren't they? They're not the answers for x. So we say 2x equals. So where is cosine 1/2? You're right, the first one is going to be here at pi over 3. Positive 1/2 is also going to be here with cosine, isn't it? It's x-axis. What's that one over there? That pi over 3? Okay, we've gone around once. To do that, we've got to get this again 2 more times, both those, 2 more times. Let's start writing down our answers. Pi over 3 on the first rotation, 5 pi over 3 in the second rotation. When you get quicker with these, it's just a matter of adding 2 pi to these answers. What's the next one? When we're around here, right? 7 pi over 3. You're adding 6 pi over 3, aren't you? Then you're going to get 11 pi over 3, adding 6 pi to this one. 6 pi over 3 is 1 rotation, so we've got to go around again because I'm looking at 6. Add another 6 to this, I get 13 pi over 3, and add another 6 to that one, I get 17 pi over 3. So just to clarify that, 2 pi over 3 is 6 pi over, 2 pi is 6 pi over 3, so I'm just adding that, making it simple addition for me. If I know 2x is all those, what's x? Right. Is this what you got? That's 2x. I need x for the answer. So what do I do? You don't know? Divide by 2. If, in general, in algebra, 2x is equal to 4, what does x equal? 2, not 8. Same principle here. All those answers are answers for x. So the first answer would be x, 6, and so on. Dividing, they'll all be over 6, won't they? Just divide. Does that make sense? So if I have 2x is equal to 1/3, what is x equal to? Well, a little bit trickier because we have to divide both sides by 2. Divide this by 2, that's okay, that's just x, but if I divide 1/3 by 2, how do I write that? Say divide by 2 if I want. I take that little bit aside, 1/2 or 1/3 divided by 2, so that's divided by 2 over 1, multiplied by 1 over 2. So that's how we get 1/6, that's how the denominator. Or you just go, that 2 is going to multiply it out. Okay. That's question 8b. 8c. Whose was 8c? John.
We got like the values, I didn't like, okay, you have to divide it by 2, I didn't know how to do that.
Okay, so let's say we've done this. So this one, 8b, I'm not going to do it, 8c, sorry. It had a different, it was x plus 3, was it cosine x plus, Is this it? Is equal to half. Okay. So you got down to this stage, is it?
Yeah.
Cosine x plus pi over 3 is equal to all these same figures.
Yeah. Or you don't go to the 7 part. Or
Do we have all the same answers here?
yeah.
Because it's only up to 3 pi. It's not 2 times this. Yeah. Okay. So you pi over 3, 5 pi over 3, 7 pi over 3. So that's 1.5 rotations for 3 pi in this question. And you're going now what? Yeah. Okay, so I want, it's not cos, it's just x plus 3. So I want x. Similar process. It's an algebra process at this stage. Each one of these is a solution to this. So let's just take one of them aside. X plus pi over 3 is equal to pi over 3. How do I solve this? Well, in general, if x plus 2 is equal to 2, what does x mean? 0, yeah, because you can subtract 2 from both sides, you end up with 0. So if I subtract pi over 3, I end up with 0. That's my first value. So if you want to think about it, moving this to the other side, but I got to do it to each one. This has got to subtract pi over 3. This one's got to subtract pi over 3, because they're all individual answers. So the next one would be 4 pi over 3. The last one would be 6 pi over 3, which is 2 pi simplified. Okay. And that will come into play again in question 12, right, which we'll do in a little bit. Question 10c. Whose is this? So this one, right, tan squared something, is that x over 2, I think. Correct me if I write it wrong here. Third. Okay, and this is the domain is between 0 and 2 pi. So, Georgina, what was your first step on this one? What do you think about doing? Square root. Okay, cool, yeah. So I don't want tan squared anything, so we can rewrite this like that. That's the same as that. That's allowed. Okay. And then you said, all right, if I square root this side, I'll end up with tan x over 2. If I square root this side, I'll end up with what? Okay, square root of that, which we can say is square root of 1 is 1. Square root, okay, so that's a known angle. Any issues? Is that what you wrote? You didn't do this thing? No? Do you think that might be the reason you got the question wrong from then on? Did you get like half the answers? Avoiding A. Okay, we'll continue then. Do we need to do anything with the domain here, or is that cool?
Isn't it x over 2?
Yeah, so it is 0, and it's now x over 2. What is the 2 pi?
Yeah,
It's just going to be pi, isn't it?
I didn't do that.
Didn't do that either. Yeah, but you still should have got some answers, maybe some answers, right? This is our domain. Tells me I only need to do a half rotation. Okay. But tan can be plus or minus root 3. So let's look at that. X over 2 will equal the end we're looking at. We are only looking in the first and second quadrants, where it's going to be 1 over root 3, and this is where we need to know our reference angle. 1 over root 3 tan is pi over 3. Pi over 6, yeah. Sine is, think of sine as the logical one. Sine gets, the ratio gets bigger, the bigger the angle. I know this is not got specifically to do with tan yet, but this tells me the cosine is winning, and the cosine is bigger when the angle is smaller. Maybe that's a way of remembering it, maybe it's not. Okay, so we pi over 6 is a reference angle, so that's in the Maybe that's another problem you've had. Oh,
No,
well, I might as well finish this. It's 3 problems in one question. That's not good. So I might as well finish it. You tell me what I write here. Okay. Is there going to be one here? No?
oh wait, yes,
Okay.
which is 5.
5 pi over 6?
Yeah.
Any more? But it's also a positive and negative in these 2 problems, isn't it? Very good. Okay, what do I do to finish? Times by 2 to get rid of the division of 2. Yes, this doubled is going to be pi over 3. This doubled is going to be 10 pi over 6, which is 5 pi over 3. So you could write 2 pi over 6 and then simplify it if you want. That's okay if you want to take an extra line. All right, so we've done over on to 12. 12 is definitely issue full. 12C seems to be very easy, but the other 3 are very difficult. Maybe not. All right, who want to do 12A?
Me.
I'm going to ask you all the questions, Bella. Excited?
Oh.
Cosine x minus 2 pi over 3 is equal to half. Yeah. Oh. Weird domain, weird function.
Yeah, that's what I struggled with, the negative 2 pi.
Okay. So this affects this, isn't it?
Yeah.
Okay, so let's do that. It's x minus 2 pi over 3. All right, now we need to fix these 2. Where I start and finish. How do I do it?
I think I don't
That's
know.
the problem.
Yeah.
Is it subtraction of fractions?
But when I
In
did
general.
it didn't look right.
So x is between minus 2 and 2, and I change x to x minus 1. Would you be able to subtract 1 from this and this? What would this become?
Negative 3,
And this is,
1.
okay. It's the same principle, just with fractions. Okay, well, let's do that. Just shifting it all a bit. So this is going to have to be minus 2 pi minus 2 pi over 3. And this is going to have to be 2 pi minus 2 pi over 3. So this is a non-calculator question, so you have to be able to do this without a calculator.
Negative 80
Negative 8.
over 3.
Well, it's going to be negative 6. Let's just change that to 6 pi over 3 to make it apples on there. What's the other one going to be? If you guys have got all these right, just get onto the textbook and move on to the next section on trig identities. Got these right. If you didn't get them right, continue to tune in. What's the other one then?
4 pi over 3.
4 pi over 3. So this is telling us, well, where we start and finish. Let's remove this.
I'm not stuck from there.
You messed up from here now.
Yeah.
What's my reference angle? So in general, cosine theta, if it's a half, what can I say about theta?
Pi over 3.
Pi over 3. Yep. All right, so there's our reference. So we put this in. This is our angle. This is our theta. And we need every place that it is pi over 3 on a rotation. Where we start and finish is the problem. Start here, finish there. Let's just put in where pi over 3 is in general, positive a half. Let's do that first. Where is it positive? It's obviously in the first quadrant, so pi over 3 is one answer.
Yeah, and then
Down here.
Yeah.
Okay, what's that?
What do you?
What's the angle?
Oh, pi over 3. Is it?
There's a couple of ways of looking at it. It's negative pi over 3 if you're going this way, but if you're going clockwise, it's
Positive.
positive, not positive pi over 3. Remember, we start here.
2 pi.
It's 2 pi minus pi over 3 to get to
Alright.
that's the angle we're looking at. We're using this as a reference.
Yeah.
So it's, what is it? Is it 5 pi over 3?
Yeah.
It is, yeah. Okay, there are my two reference. First thing I notice is I don't actually need the 5 pi over 3 because 4 pi over 3 is our end point. But I will need, this is also, as I said, negative pi over 3 if we're going starting the other way. Where do we need to start? Negative 8 pi over 3. Start going backwards. That'll be negative 2 pi. It's more than that though, it's negative 8 pi over 3. What quadrant is that in? So if we go backwards once around, that gives me negative 2 pi, which is negative 6 pi over 3. So I need to go further back, don't I? Start.
Yeah.
I need to get to negative 8 pi over 3. Is that going to be past this line? Remember, this line then would be, what would this line be?
Negative.
It'd be negative 9 pi over 3 going backwards.
Oh, yeah.
It's going to be in here. Okay, so let's say it's here. This is negative 8 pi over 3, and that's our starting point. Is that angle included when I start to do my rotations?
Yes.
No, 'cause you're looking for the two spots in blue.
Okay.
We already said that there are points where it's positive a half. Okay, so now we go on our rotation and we hit here. What is that angle? It's going to be negative pi over 3 the next time around, but this time around, what is it?
Negative.
You don't know? Anyone help her out? George?
Negative 7 pi.
It will be the next time around, but I think it's negative 7 pi over 3. We've gone twice around now, backwards. It's negative 7 pi over 3. Remember, we started off at negative 8 pi over 3, so we've just gone one back. We haven't gone, we'll hit it again in a second, and it will be this. Because it's going to be this, it's also negative 7 pi over 3 on a different rotation. Moving along up to here, still going to be negative. What's it going to be? Difficult, yeah. How many pi over 3s between these two? What's the angle between these two?
Negative 6 pi.
That's here. It's just going to be one less. One more.
Negative 5.
Negative 5 pi over 3, yeah. Tricky. Very tricky to get those right. I think it's a good idea to draw it and then put in these things. So you just work off those. Right, that's, we've gone around. Now we're just at negative pi here. We're finally getting around to here again. This time around, it's negative pi over 3. Go back and put that once. Then we keep going. Where do we stop? We stop at 4 pi over 3. This one, now we're into positives. So pi over 3 is in there as well. I don't think there's any more answers. Because we stop at 4 pi over 3. The next one around is 5 pi over 3.
Oh, my brain.
Not finished yet.
Come on.
I want x equals. Got to do the same process as I did in the other questions. Add 2 pi over 3 to each of these answers. So the first one will be negative 5 pi over 3, adding 2 pi over 3. Negative 3 pi over 3, which is negative pi. positive pi over 3 when I add 2 pi. Remember, I'm adding 2 pi over 3 to all these. Because it's negative here, yeah, it's over there, it's going to be positive. The last one, I think, is going to be positive 3 pi over 3, which is pi. I hope that's the right answer. Yeah. It is. Okay.
Just to because that's kind of
B? Are you saying B or D? D, the last one, yeah, we can.
I don't have time to anymore, yeah. Okay. You can see how long these take?
Wait, so if
My
we were to
brain.
take this in an exam,
Yes.
like would it be a question like that? Like from 8 to
Would it be? It could be. It could be. It'd probably be like a 6 or 7 mark question, which gives you about 7 or 8 minutes to do it. It would be difficult if you got this. If you got a 12D, it would be, yeah,
Yeah.
it would not be easy.
Time consuming.
Time consuming with lots of places to make little errors. And let's do it so. 2 sine 2. Oh, goodness. X minus pi over 3 minus root 3. What's our domain? 0 and 2.
It's not that different.
It's what?
It's just.
Oh, it's not yet. Okay, sorry, jumping there. Yeah, thank you.
Mine is fine.
All right, so a lot of things to go through. I'd like to get the domain out of the way first. So the domain is no longer between 0 and 0 and 2 pi anyway, but it's the angle is no longer x. What is the angle? Is it that? Laura, what did you use? Is this your question? What did you do that? You did. Okay. Yeah. Well, think about it. If it was sine 2x, you would change the domain to 2x. This is just 2x minus pi over 3. So it's like a double transformation. So you do both in one. So that means I got to do that to this. Ooh. Well, you can. Oh, sorry. Yeah, you're right. It's not just 2x. Something is going to happen. What do I do? Maybe look at a simpler example. 2x minus 1. If the original was x, between 0 and just pick a number. You want to change this. Well, I can simplify that. Maybe that helps. 2x minus 2. Maybe that helps, maybe it doesn't. What does 4 need to change to? Laura, your question?
But I do this like by experience.
Yeah.
And then minus.
You see a mistake?
Yes.
Yeah, the 2 is applied to both the x and the minus pi over 3, isn't it? So what this is actually is 2x minus 2 pi over 3. So it was x, you need to double it and subtract 2 pi over 3. So I would, if it was this case, I would double 4 and subtract 2. That'd be 6 then, yeah? Double 0 and then subtract 2, and be left with just minus 2. So that's perhaps where you went wrong, Laura, if you went wrong. So that's going to be minus 2 pi over 3 here. Double 0, I won't put that in this. Double 0, take away 2 pi over 3. This one, double 4 pi, or 2 pi, 4 pi. Take away 2 pi over 3 is what? maybe I'll write it. 4 pi, take away 2 pi over 3. 2, what? 10 pi. 10 pi. Equals 3. Okay, that's that. Maybe that could be our mistake. Our reference angle then, perhaps I'll just do it up here as well, is going to be sine. If I divide everything by 2, the sine of the angle is minus 3 over 2, whatever that angle is, and it's got some weird things going on with x. In general, sine minus 3 over 2, or sine 3 over 2, as a reference, is pi over 3, thank you. Okay, so we're looking for where it's negative. Where sine is negative is going to be in here and here, yeah? Okay, so what's my angle here? It's a terrible circle. Here. Angle here is going to be pi over 3, isn't it? It can also be negative pi over 3, depending on what direction you're going. Angle here, 4 pi over 3. Need that. So, oh, it would be negative. Would it be negative 2 pi over 3? Negative 2 pi over 3 if you're going negative direction. I'm just taking away 6 pi over 3 from both those to get that position. All right, I need to start at negative 2 pi over 3. So I start here. Oh, look, that was one of the ones that's included. So I'll say that 2x minus 2 pi over 3 is equal to, this angle is equal to minus 2 pi over 3 anyway. First one. Next time it hits, we're going this way, minus pi over 3. Next time it hits is going to come around again, is 4 pi over 3. And next time, 5 pi over 3. We're still going around until 10 pi. Where's 10 pi situated? Is this included or not? The next time around. Keep adding 6 pi over 3. Also 10 pi over 3. If I keep adding 6 pi over 3, that one there will also be 10 pi over 3. So 10 pi over 3 is included, but that's the last one. 6 pi over 3 is 2 pi, and 2 pi is a full rotation. So I've just turned 2 pi, I've just gone, all right, every time in the rotation, it's going to hit that every 2 pi limit. And just for ease of addition and subtraction, I do 6 pi. Yeah. Each one of these, then, you must add and divide by 2. Same as if you have the equation 2x minus 2 is equal to 3. How would I solve it? Add 2 to both sides. Divide by 2. So add this to each one of those and then divide the answer by 2. So x is equal to, well, plus 2 pi over 3, then divide by 2. First answer is, I think, 0. Second answer is plus this pi over 3, pi over 6, is it? 2 pi over 3, 6 pi over 3, divided by 2, 6 pi over 6. Pi. 7 pi over 3 divided by 2. 7 pi over 6. You can do this. I'll just run out of time. Plus 12 pi over 3 divided by 2. 12 pi over 6. Those the answers? Yes. Sweet. Very difficult. The main part is probably the most difficult thing. But what did I do over here? I know my rules of algebra pretty well. Should do. So I just put in algebra, and then I just thought about it. Rather than trying to do it all at once and maybe get it wrong, make sure it makes logical sense in algebra if you're applying the rules of algebra to inequalities. It's a good idea. Now, we got nowhere near any of the new stuff, so that's okay. We'll start that on Monday. Okay. We'll see you guys on Monday.